2019 Calculus A, B, and BC, number 3. What do we have here? We have a continuous function on the interval from -6 to 5, and we have that graph there. We know that's 2 lines, and that curve shape is part of a circle. And the center of that circle is at 5, 3. So that center is 5, 3. That gives us the radius. That's why they gave that to you. It is known that the point 3 minus radical 5 is on the graph of f. So we know that point there is 3 minus radical 5. 5. So let's do this. Partay. So we want the integral, or we have the integral from -6 to 5 is 7. And we want from -6 to 2. To me, when I see this, it screams of breaking an integral into 2 parts. So this is from -6 to 5. This goes all the way to 2. Or it just stops at -2. So that is less. So this one here, it goes from here to here. That's -6 to -2. And then this one here, it goes from -6 to -5. Or to +5. Maybe I should do, it's my dishwasher driving you nuts there. So if you look at this, here's the logic behind it. We are going to look at another region from here to here. And that's going to be from -2 all the way to 5. So that's what we're going to write out. We will say that the integral from -6 to 5 is equal to the red one, which is from -6 to -2, plus the green one, which is from -2 to 5. And we are given -6 to 5 is 7. We're told that. And then we want to find -6 to 2. So we want to find this one, or -6 to -2. But this is the one. Okay, how do you find an integral from a graph? It's going to be the net area. So we want to take the area above the x-axis, that area, and that area, and that area, and we want to subtract that area. So 3 pieces on top and 1 on the bottom. So here we go. First, we're going to do this piece here. The area of a triangle is 1/2 base times height. The base is 1 and the height's 1. So it's 1/2 the base times the height. Now I'm going to add this triangle to the left. That's 1/2 the base. The base is 1.5. And the height is 3. And then this is where it gets weird. This, how do you get the area under this curve? So here is what we're going to do. We are going to take the area. Ooh, can I make that hollow? Ooh, it's snapping too. Yeah, I don't like that. Okay, I'll just talk this out with you guys. So we are going to take the area of the whole square here. See this piece here? we're going to take the area of the whole square. So that's going to be a 3 by 3. And we're going to subtract the area of a quarter circle, which is pi r squared over 4. So that's the area of this region. Now from that, we have to subtract the area of the triangle down here. It's 1/2. The base is 3/2 and the height's 1. 1/2, 3/2, and the height's 1. Wow. That's pretty ugly, really. So to solve for this integral is going to be this 7 here minus all of that. That would go here. I would just write that whole thing out in brackets or parentheses. For fun, you should never do this. I'm going to simplify that. So this is 1/2. This is 9/4. Whoa. This is 9. That is 9 pi over 4. Whoops, that's so backwards. And this part to the right here is minus 3/4. I'm doing this partly to make sure I'm getting the right answer as the solutions. So I'm going to make my common denominator 4. So this first one here is going to be 2/4, and 9/4 is 11/4. And 11/4 minus 3/4 is 8/4. It's 2 plus 9. That's all 11 minus 9 pi over 4. And then 7, distribute that minus to both. 7 minus 11 is negative 4, and that's going to be plus 9 pi over 4. Is that right? Yes, that's what they got. But I would leave it in this stage, 7 minus, and leave all that as is. Why simplify that? Why take a chance on that? It's foolish. Do not do it. It's not worth it. All right, let me clear this mess up. I made a mess here. Oh, I don't want to. Yeah, I want to leave that part there. Okay, I want to leave the point they gave us right there. Okay, part B. So this is just the properties of integration. You want to split this up because that's ugly. I don't know how to do that. But you can pull the 2 out in front and do f prime of x dx. And then that other part, the 4, write it separately. That's one of the rules you learned. And let's see. Okay, we can do this. So here, the f prime, you can't do net area because this is f, not f prime. So you have to actually find the antiderivative of that. I'm going to do that down here. Sorry for the lack of organization. So the antiderivative of f prime is just f of x from 3 to 5. And the antiderivative of 4 is going to be 4x from 3 to 5. It's going to be 2 f of 5 minus f of 3 plus 4 times 5 minus 4 times 3. So from the graph, you can get f of 5 and f of 3. F of 5 is clearly 0. F of 3 they told us is 3 minus radical 5. And make sure you put that in parentheses because you're subtracting that whole thing. If you don't, your answer is going to be wrong. And this part you can leave as this. Actually, that should be your final answer. You shouldn't go any further than that. But for the sake of making sure that I did this right, I'm going to distribute that 2. We get negative 6 plus 2 radical 5 plus 20 minus 12. Combine that, that's negative 18. That's going to be 2 plus 2 radical 5. Again, you should have stopped there. And that's part C. Or B. Part B. So we're good with that. So that was B. Now we're going to go to C. Wow, we're out of room. They didn't give us much room on this problem. So I'm going to erase all this here. And I'm going to box all of this stuff to get out of the way. And oh, excuse me. Ooh, I got another one. Ooh. Part C. Given function g is given by that integral, find the absolute minimum value. Okay, I like this question. I like it. I just don't like that they didn't give me much room. So, minimum. How do you find absolute minimums? You have to know they occur at critical points and endpoints. So to find the critical points, we take the derivative of g, and there's a fundamental theorem. It says if that's a constant and that matches that variable, all you do is plug that in there because you're taking the derivative of the integral. They kind of like cancel each other out. So that's just going to be f of x. Now, if this were a function, you still plug it in, but by the chain rule, you'd have to multiply by the derivative of that also. So we're going to set this equal to 0 because that's what critical points are, 0 or undefined. When does f of x equal 0? Well, from this graph, we could see at negative 1, 1/2, and 5 at x equal negative 1/2, was it? No, 1 and 1/2. Negative, negative 1 and 1/2. And that 5 is an endpoint, so we're not going to concern ourselves with that. But now, to find the maximum value, you have to find the value at the left endpoint, the value at both critical points, and the value at the endpoint. Now, if one of your critical points is a rel min, technically you wouldn't have to check that. You'd probably have to justify why you didn't check that. But let's just go ahead and figure this out. So negative 2, that one's easy. Plug in negative 2 into my g. I get negative 2 to negative 2 of f of t dt. Clear that 0. The net area from negative 2 to 2 is going to be 0. You're not going to have anything. So then we're going to do the integral from negative 2 to negative 1 of f. So negative 2 to negative 1, that's going to be the area of that. That's going to be 1/2. And then the integral from negative 2 to 1/2. So that's going to be the net area. So it's going to be that, and we have to subtract that yellow part. So it's going to be 1/2. The area of this is 3/2 times 1. So it's going to be 1/2, 1.5 times 1. That's going to be 3/4. So it's going to be 1/2 minus 3/4. That's going to be negative 1/4. And then g at 5. So that's going to be the net area from here to here. We found that. We did that earlier. Isn't that all of this? Let me double check. It's the integral from -2 to 5. Yeah, we did that. See? -2 to 5 is all of that. And I simplified all that. Now, it was 11 minus 9 pi over 4. Whoa. Oh, no. They want the absolute maximum. So that's out. That is out. What's bigger, this or this? Let's kind of contemplate this. So let's do an approximation. So pi is about 3. So 9 times 3 is 27. So this is kind of like 11 minus 27 over 4. And 4 times what? 6 is 24. 4 times 7 would be 28. So maybe that's like 7. 11 minus 7 is 3. I mean, clearly that's going to be bigger. That's bigger than 1/2. So our maximum value is that. So I'm going to state that. Let's see what the question asks. The function g is given. Find the absolute maximum value of g on the interval. Okay, so they don't want the x-coordinate where it occurs or the t. They just want to know, actually x-coordinate, they just want to know what the absolute maximum value. So you're going to say g has a maximum of 11 minus 9 pi over 4 on the interval from, and that was -2 to 5. All right, so that is part C. Part D, I am thinking again, L'Hopital's. It just looks like it's going to be L'Hopital's. We will see. So let's take the limit of the top separate from the bottom. So it's going to be 10 to the 1. So 10 to the x is a continuous function. So to find the limit, you actually just find the value at the point. And then f prime, let's see what this says. F is continuous. So that means, let's see. All right, so what is f prime at 10? F prime at 10 we would get 10 minus 3. F prime at 10 is the slope. Whoa, 10? Oh, 1. I don't know where the 10's coming from. You're just tired. What's the slope at 1? The slope here, let's look at the rise. It's 1, 2, 3, 4, and 2. So the slope's 2. So the derivative at 1 is 2. Oh, wow. That's going to be 6. Oh, no. 10 minus 6, not 6. Wow, Yoshida. 10 minus 6 is 4. And let's do the bottom. The limit as x approaches 1 of f of x minus arctan x. So that's going to be f of 1 minus arctan of 1. What's f of 1? F of 1 is just going to be 1 from the graph. And arctan is asking what angle. What angle has a tangent of 1? That's going to be pi over 4. So this limit is going to be 4 over 1 minus pi over 4. That's it. We are finished. Bye.